Thanks again to the Chariot folks. They've done putting on a great show today. So it's great to be back in live in front of actual people and not be virtual. So I'm happy about that, to see happy smiling faces in the room. So happy to be here. I noticed while I was out there, they have this option. I was looking for water and I found this and I thought it was pretty great. They more ocean, less plastic, carbon neutral can out there of water. So it's pretty great. So I'm here today to talk your ear off about green software and how you can use the SCI, the software carbon intensity, to measure and then reduce your carbon footprint of your software systems. A lot of you are in here because you're also concerned about our planet and the rising temperatures. And so this slide is really just, what are we trying to battle and what does a half-degree change really mean, and with regards to heat and species loss and decline in coral reefs and also crop yields. So I know all of you have seen, the more extreme weather and myself having grandchildren, and I want them to see grandchildren, became more involved with the sustainability movement. I do have a joke for you to get you started in case you haven't had enough coffee this morning. So I grabbed a couple of these from the internet yesterday. So if Mac users cared more about the environment more than Windows users, then why do Macs have trash cans and Windows have a recycle bin? Well, good, I got a chuckle. Jay Leno also says, according to a new UN report, the global warming outlook is much worse than originally predicted, which is pretty bad since they originally predicted it would destroy the planet. So, all right, so who am I? My name is Tammy Adkins McClellan. You can find me on LinkedIn with that name or the Tech Grandma. Been around for quite a while in the tech industry. I have over 30 years of tech experience. Started out with system engineering work, been a software developer for most of that time. I've come up with all the tech products throughout the year. I joined the Green Software Foundation about 2 years ago, and this is a foundation that was co-founded by Microsoft, as well as some other tech giants like GitHub, Accenture, Avanade, ThoughtWorks. So it's a collaboration of multiple tech companies. And so they formed this Green Software Foundation, and it's been in effect for a little over about a year and a half. So recently I was elected as the chair of the Oversight Committee. And so what that means is I'm helping to oversee the technology that's involved with advancing sustainability in our software. And I also co-chair the community working group. So how do we advocate and get that message out to folks? I work for Microsoft. I'm a cloud solution architect, developer advocate. So I work with customers and our customers' developers. And coincidentally, I'm also a farmer in Michigan. So I have a small 10-acre farm where I farm veggies and flowers, and we have chickens, and we try to farm in a very sustainable way, which is the love of my life. The name of our farm is Wonderful Tiny Farm, or WTF. My husband came up with that. I can't take credit. So on its own, software doesn't consume energy or emit any harmful discharge. The problem lies in the way software is developed for use, and then in the way it's used. So software runs on hardware, and the former continues to grow, and so the reliance on the machines to make it run. For example, someone said earlier, cryptocurrency, but also, blockchain drives some of the most advanced green solutions available, such as microgrids that allow residents to trade environmentally friendly energy. And this software innovation is behind the development of cryptocurrency. In 2019, researchers at the University of Cambridge estimated that the energy needed to maintain the Bitcoin network surpassed the entire nation of Switzerland. Training a single neural network model today can emit as much carbon as 5 cars in their lifetime, and the amount of computational power required to run large AI training models has been increasing exponentially with 3 to 4 month doubling time. So building green software translates into higher quality products, leaner, cleaner, and more fit for its purpose. And so newer application architectures such as serverless computing enables even more control over capacity and by extension energy consumption. Serverless computing, for example, efficiently shares infrastructure resources by executing functions only on demand. And since it bills for execution time, it compels programmers to improve their code efficiencies. Sorry, I'm still trying to get my coffee in this morning. So let's talk a little bit about carbon footprint versus carbon handprint. So this is really about shifting from the negative into doing something about it, right? So our carbon footprint is all the ways we damage the planet, negative, depressive, planet is better off without it. And the handprint is all the things to make the planet better. So take the footprint as our baseline, and then our goal is to grow your handprint better than the footprint. So we're going to focus on the handprint. Let's talk a little bit about the Green Software Foundation. I gave a little bit of intro about it. I think we're up to about 50 members now. And each one of those members have employees, and I think we're totaling about 1.5 million of folks that are a part of the Green Software Foundation. And so the goal and the mission here is to build a trusted ecosystem of people, standards, toolings, and best practices for green software. And our mission is really to change how we build so that there are 0 harmful environmental effects. And the vision is building a trusted ecosystem of people, standards, toolings, and best practices. And then who we serve are primarily software practitioners, so also leaders, policymakers, students, really anyone that plays a role in software. So what we're trying to do is advocate in the areas and make changes in our tech culture, our knowledge, our tooling, and so that environmental effects from software are made a priority, studied, taught, and understood, and then easy to act upon. And we have our little pie chart here of the fundamentals of green software, and we'll go through and talk about each one of these as we advance through the presentation. In the first one, we're going to start off with learning. So what are the principles associated with green software? And so what makes software green? Carbon efficiency. And how do you do that? Well, you emit the least amount of carbon possible. And you do that through energy efficiency, consuming the least amount of electricity possible, hardware efficiency, using the least amount of embodied carbon possible, and then being carbon aware. So do more when the electricity is clean and less when it's dirty. So energy efficiency, it really is the ability to do work, right? Electrical energy is produced from burning fossil fuels, which is the single most significant cause of carbon emissions. All the software, whether it runs, wherever it runs, requires electrical energy. And green software takes the responsibility for the energy consumed by its products. Hardware, the hardware used in the process of creating your software is an important element to consider for a green software practitioner. You will see how embodied carbon is a hidden cost when it comes to hardware and the different measures you can take to reduce the impact that the creation, destruction, and running of this hardware involves. For example, extending its lifetime or switching to cloud servers. And being carbon aware. So not all electricity is produced the same way. Different locations and different times of day may require different energy sources, which in turn have carbon emissions. Factors that can influence this include weather conditions and the demand for compute. Being carbon aware means understanding the carbon emissions in a particular place at a particular time. I'm going to try some of this carbon neutral water. All right, let's talk a little bit about the SCI and offsets. So there are some limitations to carbon offsets, and that is why they are not considered in the organizational's SCI score. For example, imagine two applications, both running on a cloud platform that is 100% carbon offset and matched by 100% renewable energy. Application A uses resources effectively, whereas application B does not. If the SCI considered offsets, both the applications would score 0. Organizations need to have a plan for how to both eliminate and neutralize emissions, and the SCI helps them to drive the elimination of emissions due to software. So the SCI is focused on reduction and not neutralization. All right, we're back to our pie chart again. And this time we're going to talk a little bit about the SCI specification itself. the moment you've all been waiting for. So we can't improve what we can't measure, and so we came up with the SCI, the software carbon intensity. So there's a link there. I don't know if this is available online, but if you do want to go out, there's a whole guidance around this at the SCI guidance on the greensoftware.foundation website. So there was a study done by Texas State University, and so the conclusions of this study was really when looking at carbon emissions of various foundation models, the study concluded that the environmental impact of the foundation models could be quantifiably measured and compared, that SCI is an effective metric to evaluate the carbon impact of different foundation models at the inference stage, and it is possible to replace carbon-intensive foundation models with more efficient ones without sacrificing model quality. So deploying foundational models on more efficient hardware can significantly reduce your SCI. And at its core, the core characteristics, the SCI is sensitive to carbon awareness, energy efficiency, and hardware efficiency, like we talked about. It takes a system impact view. It's easy to implement. Well, it's becoming easier to implement. And the SCI encourages the use of granular data. So, and the exclusion is only actions that eliminate emissions reduce an SCI score. As such, an SCI score cannot be reduced through carbon offsets, such as market-based measures. And here we go. This is the SCI calculation. So it's really made up of 4 parts. It takes into account energy. So the energy consumed by software by kilowatts per hour times I, which is carbon emitted through kilowatts per hour of energy, the grams of CO2 equivalent to kilowatts per hour, plus M is our embodied carbon. And so carbon emitted through the hardware that the software is running on. And then per R would be our functional unit. So this is how our software scales. For example, this would be per user or per device or per time. So we're going to go through how we're calculating each section of this. There are several ways that we can calculate energy in software. One of them is through APIs. So integrating APIs to provide the energy values at runtime. Performance engineering techniques, which is when you measure runtime, like CPU utilization, memory, etc., and you use these to calculate energy, which I'm actually going to show you a few use cases, and they all are using this method of calculating energy. So there's going to be lots of math to boggle your mind in this space. I will tell you that we are working also to make this much easier through an API, and we'll talk about that later on. There's also tools, tool base that you can integrate with your software. running on desktop or servers that provide energy data. The new version of Windows has a carbon aware feature to it, so it actually displays the amount of carbon that the application is using. And then of course, there's public sources out there that you can use. Because this is emerging tech, things are relatively new. Right now, we're using coefficients to determine utilization, whether it's CPU and memory. And this is a very naive model to convert utilization to energy consumption. And there's an article out there by Benjamin Davis, and he's on medium.com, in where he did a study, and this is actually based on AWS. I'll post that article if anyone's interested. But I actually used this coefficient data to use in some of my case studies. So how do you convert utilization to power? So the conversion is documented in the SCI Open Data Project and is available here, but it really is the output. The output is called TDP coefficient, and the TDP coefficient is then multiplied by thermal design power rating of the specific component. And so what is TDP? Well, it's the number that helps with designing what cooling the component needs. Although this has an impact on energy consumption, it does not contribute directly to the estimation. And then, of course, what the formula for the power calculation is. And that really is the number of cores plus the power consumption of the CPU, the GPU, the number of memory sticks, and the power consumption of memory. Do your brains hurt yet? I've been doing this for about a year and looking at this data. It is quite intense to get in, and advancing this and coming up with more APIs to make it easier is definitely going to be value add. Now let's talk about our I value. So that's really the grid intensity of where your device is running. So there are multiple ways to do that. You can do it through APIs, and there's a few out there that are pretty good. One of them is Watt Time, electricity maps. There are some database and sources out there as well. And this is really getting the marginal carbon intensity value from the data sources or emission databases. And then this is also a little tricky because you need to rely on the manufacturer of the device in some cases. We're doing some guesstimations here, but this is the calculation for determining embedded carbon in your devices. So it's so marginal is TE plus TS plus RS. So total embodied emissions, meaning the sum of the life cycle assessment emissions for all hardware components. Time sharing, meaning that it shares the total lifespan of the hardware reserved for use for software. And then resource share, so meaning the share of the total available resources of the hardware reserved by the software. So embodied carbon um, is the amount of carbon that's emitted during the creation and the disposal of a device, and also its use. So it's the life cycle of that device. When software runs on a device, a fraction of the total embodied emissions of the device is allocated to the software. This is the value of M that you need to calculate in your SCI equation. If your application is running on the cloud, the hardware resources would be shared by multiple applications. And to calculate the share of the embodied carbon for your software application, you can use this equation. Although I will tell you, these numbers are still really hard to get depending on your cloud provider. I know at Microsoft, we're working hard to get this data, but when you're looking at multiple workloads from different customers sharing a device, it's sometimes very difficult to kind of separate those and determine exactly what application is using what. It's a big problem that we're all looking to solve. So now we're going to look at some of the use cases that have been done. I'm highlighting two of these because I did these two. There's lots of others out there that other people have done as well. So we continue to build off of each other's work and learn from each other. But feel free, if you go out to the Green Software Foundation website, you'll see the SCI guidance. And in there will be everything that I talked about here, as well as a lot of documented use cases. But we're going to start with something really simple. For me, a lot of times I tend to jump in with all the complexity in the world and start building things as I think software developers do, instead of taking a step back and starting with its simplest form and then building on this. I've learned that lesson in my life too many times. So for this one, I mentioned I have a small farm, and what I wanted, one of the experiments I wanted to do was to gather environmental data about my farm and to better manage it. So for instance, I want to measure soil moisture, and so that I water the plants when they need water and not on a schedule when I think they should be watered, which is the way it's usually done. So I bought a Raspberry Pi and some sensors, and on there were temperature, humidity, and soil. And I set up my Raspberry Pi to collect this data. Now, the boundaries of this use case is my Raspberry Pi. So I could have gone further beyond that, started looking at network traffic and measuring that. Then, of course, I was sending the IoT data to the cloud. But for this one, it's just the device. And so real simple, real easy to understand. So again, we have our SCI, E times I, I'm sorry, that should be plus M, not times M, per R. And so what I did was I bought a energy meter and I plugged in my Raspberry Pi. And so I was getting directly the amount of energy the Raspberry Pi was using. I went out to our energy provider and, figured out how much energy I was being charged per hour. So it was fairly straightforward, fairly simple. And so for one day, I found I was using 0.003 kilowatts per hour. And so what I did, because my R was going to be 1 year's worth of time, then I just times that by 365 days to get my year. The I, so I, in the startup of the GSI, so watt time and electricity maps are part of the GSF. And I contacted, at that time, I didn't have access to the API. I contacted my good friend Henry at Watt Time, and he actually gave me the grid intensity for my area. So I live in Chelsea, Michigan, so he was able to look it up, and he gave this to me. There's APIs out there. They're fairly accessible now, so you can get this data yourself. So that number was 0.713 kilograms per kilowatt hour. Now the M was tricky. I contacted Raspberry Pi and I said, hey guys, can you tell me what your embedded carbon costs for making a Raspberry Pi is? And they said, we really have no clue. But, you know, and I haven't checked, but hopefully they have that data. That was well over a year ago that I asked them about that. But I did find an article where it was a smartphone, and somebody had figured out the embedded carbon in a smartphone was 55 kilograms for a 3-year lifespan of that device. And so I figured that was roughly pretty close to my Raspberry Pi. So I took that number as a baseline. So over 1 year's time, wow, I actually don't have it on here. But my score was 19.1, I believe. So that was 19.1 grams of CO2 equivalent for 1 year's time. So very small, actually. So then I went into use case number 2. A little bit more complex. Now we have cloud resources involved. So one of the folks that I work with, one of the companies I work with is Dow. In their corporate headquarters is in Midland, Michigan. And so they've come along with my journey. They've really been kind of a captured audience. And so we work with developers there. And so we did this case study together. They were going through the process of trying to figure out which graph database would be good for their enterprise. So they were looking at choosing between multiple graph databases for their enterprise. So they were looking at cost, they were looking at performance, and then we also looked at carbon. So we measured all of those things, but for this, you'll see the carbon measurements for both Neo4j and TigerGraph DB. Along with that, they used an API to do some load tests, and so we included the API as well. So we could have expanded this even greater and said, let's measure the network traffic and the laptop that it was, you know, the APIs were being called on. But for this, we stuck with the APIs in the database. All right. So what I'm going to walk you through now are some of the numbers for each one of the components, and I'll try not to boggle your brains or mine, because because even when I go back and look at this, I have to kind of rethink and remember what it was that we did here. But in the case of energy, they were running load tests for measuring performance, and we basically in the load test we were getting CPU utilization and memory utilization. So what we did was we took those actual measurements and we used some coefficient data to kind of figure out exactly what the CPU and memory utilization was going to be for the Tiger Graph database. So this first one is Tiger Graph. So we figured out that the total E was 0.117 kilowatts per hour. And then we looked at I. So I was, again, the grid intensity, and we were looking at Azure regions. So we figured out that East and North Central, as they had workloads in both, was 554 grams of grid intensity. The embedded carbon, so there's actually in GitHub, and I have a link if anyone's interested. It's if you go to GitHub and you look at cloud carbon coefficients, they actually went through and they did this for all cloud providers. They looked at the coefficients for embedded carbon for all machine variations. So each one of the manufacturers, and they had that listed. So I took that for my carbon. So the total M ended up being 684 grams of CO2 equivalent. So we've got our E times I plus M, and our R factor here was time again, so it was over one hour. And we did the same for the API. We looked at memory allocation. We looked at energy using some of the methods that I talked about. Again, I was 554 grams, and then we took M, and we ended up with the total M was 5.46. I do have it totaled here as well. And so this ended up being our total, so much higher than my little Raspberry Pi sitting on my farm. 118 grams of CO2 equivalent for, and this is for Tiger and an API. And this is over 1 hour a day. So we did the same thing with Neo4j. Now, I don't know how many people in here are familiar with both those products. But Neo4j does have quite a bit of features that that are enjoyed by many, and so it's a little bit more bloated with what it has. And so when we looked at calculating Neo4j's graph database, it was somewhat higher. So we did the same thing with the API. And so our total actually for Neo4j was 191.44 grams of CO2 equivalent for 1 hour. So we had our baseline, and we kind of celebrated that for a little bit. And then we looked at what are some things that we could do to reduce it. So the first thing we started looking at was our grid intensity. So it was one of the simplest things you can start off doing. So they were running in an Azure region in East US and North Central. And we looked at the different regions, and we found that West US, who'd have thunk it, the West Coast, was actually had the least amount of grid intensity because they're powered more by renewables at this point. And so just the fact that if we picked that workload up and we moved it to a different region, we reduced the carbon footprint immensely. So in here, I say that we reduced the carbon overall by 44%. It was mostly due to moving to renewable to the most grid efficient area of the world, of the US, not the world. In addition to that, we found that they were using a much larger VM than what they really needed. And so what we did was we just reduced the VM tier down just one level to better match the workload that they were doing. And we ended up with a 44% reduction. Now, mind you, this is still for 1 hour, right? So every hour of the day, if you times that by how many hours in a day, how many days in a year, I mean, this is consistent carbon savings just by doing two simple things, really. We didn't do anything in the code. We just looked at where it was running and what size machine it was running on to get that reduction. So we talked about the SCI. We talked about a couple of use cases. There are a few more out there if you want to go to, I believe it's SCI. If you Google SCI guidance, you'll find that as well as more use cases. There is one out there that is kind of a typical web application use case. So a database, a web app, an API, and that was probably the first cloud-based use case that we have out there. There's another one done by, I think ThoughtWorks, where they go a little bit further and they're looking at network traffic and routers. I mean, you can really kind of go crazy when you're looking at doing use cases. So if you set clear boundaries at first of what you want to measure, and then start expanding that as you go further in your journey, you'll have much better success, and you'll really understand what's involved there. And for the developers that are in the room here, I do have some ways that you guys can contribute if this is something you're passionate about. So we started a couple of open source projects. One of them is called the Carbon Aware SDK. So at its core, the Carbon Aware SDK is a web API and a CLI to assist in building carbon aware software. The functionality across the CLI and Web API is identical by design, and they're actually thinking of expanding that in different areas too. So what it does is it helps standardize, driving standardization of the interface into the data providers. So the third-party APIs do differ and results can vary in unit of measurement. The SDK takes care of the conversion, which is valuable with integrated data sources. So it's very collaborative in that it's open source. It manages their centralized secret and key management. So the ability to manage keys to third-party APIs, changes to keys, or rotation can be done in a centralized and controlled manner without exposing the keys to the app dev teams. It allows you to be auditable. Because the API is centralized, this gives you the ability to audit a controlled environment for when decisions are made, and it is an aggregated resource. So a feature that we have in the roadmap is the ability to aggregate, if only I could speak English, data sources across multiple providers. Different data providers have different levels of granularity depending on the region. And it may be that the data provider A is preferred in Japan, the data provider B is preferred in the US. You also may have your own data for your data centers that you would prefer to use for on-premise workloads, which you can combine and aggregate with the third-party data providers. So really at its core here, it's a way to kind of centralize and manage all the different data sources out there for grid intensity. So this is mainly grid intensity data. So watt time is integrated in here, electricity maps, any other data provider that comes online or comes on board, or even if you have your own data sources. So if you're interested, you can go out there. I use it now for my use cases. It is free and open source. And who doesn't love the easy button, right? There's another open source project that is just being kicked off. It's still, I believe, flushed out the design. And they're going to be ready to start work on it. And it's called Carbon QL. And it's basically a way for you to get SCI data about your application. It's the easy button. So it'll also incorporate the Carbon Aware SDK inside of it. So it's also a way to get energy and embodied data. So they're going to be looking at a lot of different data sources, integrating it all together, and providing folks with the easy button. Because as you saw, we didn't go through all the nuances of doing those SCI scores, the calculations. But I'm looking forward to this, I'll tell you. Couple of things about Carbon QL, what they plan to do with it. It is going to be opinionated. So it will be the expertise in software measurement codified in software. So rather than giving you options, it gives you answers. It's ambiguous. Wherever the environment, bare metal, virtualized, mobile, IoT, Carbon QL project will always be able to give you numbers. It's declarative. You express your intentions, needs, and context, and Carbon QL selects the correct measurement methodology. For example, if you're calculating an SCI score, the Carbon QL API will return the data that meets the requirement of the SCI. Likewise, if you're calculating for GHG, Greenhouse Gas Protocol, reporting, the API will return information that meets that requirement as well. It's free, open source, doesn't cost anything. It's extendable. The API can be enhanced to leverage more advanced commercial or private models. For example, real-time electricity carbon intensity tools. And it's really for anyone that's software monitoring, products looking to add carbon as a software measurement metric, software optimization tools, looking to represent optimization in terms of carbon reductions, developer tooling, and organizations looking to measure for action the carbon emissions reduction. That's what happens when you talk too much. So I'm really excited about the evolution of this product. And if anyone's interested, go out and check it out. All right, so the last piece of our pie here is our reduction. So we did talk about reduction in some of the ways we were able to. We have a catalog out there that has a lot of patterns in it. So we'll look at a few of those things. And again, you can find this out on the Green Software Foundation's website. The catalog is out there. It looks at ways to reduce patterns for web, which when they say web, it's really centered around UX stuff, how you can design software to be carbon efficient just through the interface. There's also cloud, and we're doing lots of experiments with ML, AI and ML, and so those patterns are out there as well. So these, I think, are kind of no-brainers. They're like, you know, for any developer that's looking to be an efficient developer is going to look at, you know, how they use their resources. And of course, storage is one of them. And so just watch your storage and delete unused storage. Seems like kind of straightforward. And so what they're saying is that this is actually affecting the M value of our SCI score. The other one is what we've already talked about, is matching the utilization requirements to your VM servers. So keep an eye on the performance and actually match it up to the workload that you need. So, you know, no longer, with cloud, of course, you're allowed to be elastic. And so that's also a great benefit. As you need more, you can scale up. You're not paying to run large servers for workloads that may or may not scale at certain parts of the day. And so this allows you to be more elastic and control those efforts. But you can do the same, well, not the same, but you can apply the same logic to your on-prem servers. Time shifting. You know, do more when the grid is cleaner, do more when there's less demand on it. All of you probably got notices from your electricity companies. Here's our greatest hours of demand. If if you can shift your dishwasher to running in the evening instead of during the day, that's great. The same applies here, right? Scheduling your jobs to run in off-peak times when the demand is lower also costs you less for energy. And that, of course, is affecting our I value of the SCI. Just a couple of things to plug, my friends at Microsoft. If you've got Windows 11, there was an update that gives you carbon data about the operating system, which I think is pretty cool. And being in Microsoft, I work with a lot of the product groups around being more sustainable. And one of the most sustainable groups that I've seen so far at Microsoft is our Xbox group. They're just doing phenomenal work with being able to give you that carbon data and just making you more carbon aware, right? Whether you're buying a device, and so they have that information that's displayed, but they're also coming out with, the app versions so that we're reducing the M, so the embedded carbon. The less devices we have to make that, have a life cycle and end up somewhere at the end of its 3 years. If there's an app that you can run and install on a device that you already own and have already spent that embedded carbon data, then why not, right? And so they're really becoming very innovative in how they look and very passionate about reducing carbon on our planet. So, sustainable future of gaming for all you gamers. I swear I'm almost done. One of the other things that's available through the Green Software Foundation is you can become certified, actually. This is through the Linux Foundation, and it's a green software for practitioners. So it's really if you go out there, there's a course, takes about 2 hours. There's a completion exam at the end of that. You finish that, and now you're thinking more about sustainability when you're building your applications. We are going to be working on a more intense exam that'll be more developer focused, I believe. And then there's some additional links here. I had a thought and then it disappeared. I love it when that happens. Oh well, I'm sure I'll think of it in a few minutes. So, yep, we got some links here. And that is it. So hopefully you guys enjoyed the sustainability talk. Yay.